Hello and welcome back to the lecture of time series econometrics. In this lecture, we are going to compare the mathematical properties of AR1 and MA1 process. By now, we have derived all the mathematical properties for MA1 process as well as for the AR1 process, and we should be in a comfortable position to actually think about the different mathematical properties, and from those properties, we should be able to distinguish a MA1 process and an AR1 process. Now, for different mathematical properties, for the sake of stationarity, we actually look at mean, say mu, or let me write down this mean, variance, covariance, and correlation coefficient. Okay. So these are the different properties that we can easily obtain for AR1 and MA1. So let me write here first MA1 process and then AR1 process. Now we have seen that the mean, the expected value of the AR1 process and the MA1 process is always 0. So there is no dispute about that. So it's a constant, it's 0. So we are okay with that. Whereas for the variance, we have also seen that both of them are constant, and the value of the variance is going to be for AR1 process, for MA1 process is going to be what we have derived already is sigma square 1 plus theta square, whereas for our AR1 process it is sigma square by 1 minus phi square. We use this theta and phi operator for MA1 and AR1 process basically to represent the weight of the past period values. Now, so far as the covariance is concerned, we have some differences because when we are dealing with the covariance, for AR1 process, we get something that is more of not constant type, okay, because the covariance, it varies with the lag period, and the value of the covariance we represent as what we have derived 5 power h sigma square by 1 minus phi square. Whereas for the MA1 process, we have seen the value of the covariance varies with the depending on the value of the lag. So for lag equal to 1 or minus 1, we have covariance value theta sigma square for h equal to plus or minus 1, and it is 1 plus theta square sigma square for h equal to 0. Okay. Now we see that these values, the covariance for MA1 process has value only for h equal to 1 or h equal to 0. It doesn't have any other value for any other h, so far as MA1 process is concerned. Okay. Now for now we'll just restrict ourselves to MA1 and AR1 process, and we'll see how if the order of the processes changes, how we can see it differently. Now the other mathematical property that we see for all these processes is the correlation coefficient. So it's very simple to obtain the correlation coefficient. You simply need to divide the covariance with the variance to get the correlation coefficient. So for MA1 process, what we will get is, we will get, if I divide the covariance with variance, I will get theta by 1 plus theta square, whereas for AR1 process, I will get simply, if I divide the covariance with the variance, I will simply get rho to the power h. Okay, so these are my correlation coefficients. Now in the next lecture, we are going to plot these correlation coefficients, and we're going to see how the ACF plot, autocorrelation function plot, and we're going to see how they emerge differently for AR1 and MA1 process.